Anyway, my legendary skills of IT. Okay, Sonia, off you go again. I don't know why your chat is not coming in the main chat, but anyway, it's okay. I can see everyone's comments. We are discussing, as of now, we were supposed to do the delta H solution and delta H dot hydration calculation. Could you confirm that I have already given you the definition and equations? Could you please check and let me know that that has been done? Sonia, okay, guys, can you please confirm that we have already done the definitions of this and how to write equations? Could you please confirm? Just check your notes, please. Okay, so is the chat still comes as disabled for some reason? So why is Sonia typing separately? Sonia, can you try to say write the messages in where it says everyone? Okay. Okay, so let's have a look at how to do this delta H dot solution and hydration calculation. And what we are going to do is we are going to use Hess law here. Okay, using Hess law, we are going to do this. So what we'll best, I'll give an example. I hope you remember something about Hess law that you have done in your last year in AS level. Do you remember? Yes or no? Y for yes, N for no. How much do you remember of Hess law? You remember something? Okay. Okay. Let's have a look. I'll give you some, it's a very simple calculation. The diagram never changes. That's the good thing. So for example, if you have a question like, first of all, draw, this is A part, draw energy cycle to show delta H dot solution of NaCl. Now, what you have to understand is whenever you do, oh, finally you got it. Okay. Whenever you do this kind of questions, you must remember in your energy profile diagram, you have to use delta H dot lattice, delta H dot solution, and delta H dot hydration. You have to use all three of them. Okay. Only then this is going to work. So how that works is, okay, you want to draw energy cycle to show delta H dot solution of NaCl. Now, if you look at your notes, the last thing what you did in the class was how to write these equations. So if I ask you to write delta H dot solution for sodium chloride, you might remember we did NaCl solid dissolving in large amount of water to form Na plus aqueous and Cl minus aqueous, correct? Give me yes or no if you understand this. Everyone remembers this? Please give me yes or no. Okay. So now you have to draw a Hess cycle here. So that means you have to draw something like this. You have done this in your AS level last year. So there is an arrow here, there is an arrow here, and arrow here. And this is the curved arrow, the Hess law arrow. Now all you have to do is to incorporate all these three in your energy diagram. So solution already I incorporated. It's already here. So what is now missing is lattice and hydration. Now if you go back on your notes and check how do we how do we write hydration equations? If you remember how do we write lattice equations? So go back in your notes and check who is on the left and who is on the right. So if you go back on the notes and check, when you write lattice equation, for example, if I say I want to write delta H dot lattice for sodium chloride, correct? Your equation was you used to write NaCl solid on the right, but who was on the left? Just check the equation, please, quickly. And if you check the equations, you will find Na plus gas and Cl minus gas was on the left. Did you remember? Give me yes or no. You did this? Now, this is how we used to do lattice equations. So this is NaCl solid. So what do you need to make NaCl solid? You need sodium ion gas and sodium ion gas. Oh, sorry, chloride ion gas. So that is why sodium ion gas and chloride ion gas will come here. So as you understand, it's the gas ion which is changing to solid. So the arrow will always go like this. This on the left hand side is delta H dot lattice of sodium chloride. And always that arrow will go this way. Now we are talking of hydration. Now hydration happens. How do we write hydration equation? If you don't remember, you can go back on the last class notes and check. If you want to write hydration for sodium, you used to say sodium gas plus aqueous gives sodium ion aqueous. Do you remember this equation? Give me yes or no. Everyone remembers this equation? Please give me yes or no. Yeah. So if you just check the notes, you'll find it there. So hydration, the gas ion changes to aqueous ions. So these are my gas ions. These are the gas ions. I want to change them aqueous ions. So you understand that the hydration arrow will be like this. Do you understand? If you want, you can please open the mic and speak. It's a small group. Make use of it. So this is the hydration from gas ions to aqueous ions. Okay, so let's label. So this is delta H dot hydration sodium ion gas. This is delta H dot hydration chloride ion gas. Is this okay so far? Everyone is okay? Okay. Now, if I give you the values, will you be able to calculate the enthalpy of solution? Will you be able to do that? Hi, Siddharth. Can you hear me? This is my first slide right now. Oh, by mistake, it went to
Yes, yes,
slide
sir. I can.
number.
Yes, sir. I can hear you. Thank you.
I don't know why, for some reason, it became slide number. Hold on. So I'm just labeling this as. Can I shift it? Okay. So this is slide 1A. So we just started with the calculation of delta H dot solution and delta H dot hydration. This is the first question going on. First of all, using the Hess law, how to draw the energy diagram of NaCl. So what I'm going to do now is I'm going to give you the values. Okay, the value for this one is -771. Hydration for Na plus is -406. Hydration for chloride ion is -364. Can you use these values to calculate delta H dot solution? So I want you to now calculate delta H dot solution. How will you calculate? This is classic Hess law. As you notice here, 1 second. However, come. Up or down. Okay. Okay. Sorry, guys. So I have to calculate delta H dot solution using the Hess law math. So I'm waiting for you to give me the answer if you can by yourself at this stage. Okay, already someone has answered. So very good. That is the correct answer there. So as you notice here, the arrow directions are opposite here, you see. So if the arrow directions are opposite, I hope you remember what I taught you last year. You will change the signs. So this is -771. So delta H dot solution equals to the -771 will become +771 plus, here the arrow directions are same as it is. So that will be -406 plus -364, and someone calculate and tell me the final answer. Are you getting plus 1.0 kilojoules per mole? Okay. Okay, first of all, very, very quickly, tell me if you understood how to draw the diagram, because I'll give you some more questions for you to practice this by yourself. The good thing is the diagram never changes. It always remains as it is. So let me know if I can go to my next page and I'll give you another question for you to practice. Just keep a note. The more negative or more exothermic the delta H solution, more is the solubility of the ionic compound. So basically, with the help of the delta H dot solution, this is a very good deduction that you can make all the time. So we know NaCl is highly soluble in water, but it still a solution is +1, which is hardly anything. That is why when you slightly stir the solution, NaCl completely dissolves in water. So let me know when you're ready. I'm going to give you another question. You will first draw the diagram and then you will do the calculation. Please let me know if you're ready quickly. Then we'll go to our next page. Ready? Can I go to next page? Anytime you want, let me know if I have to go back to any previous page. Okay, let's have a look at this one. Salamat, have you taken everything?
Yes, sir.
Okay. Now, for example, I'm giving this question to you. So let's say the delta H dot lattice energy for barium hydroxide, okay, is negative 2235 kilojoules per mole. And I'm going to be teaching something different here as well. So let's say delta H dot hydration for barium ion, which is gas, is negative 1360. And let's say delta H dot hydration uh, for OH minus gas ion is also given as minus 460. And the question says calculate delta H solution of barium hydroxide. Okay, so that's why the question is. Okay, first of all, why don't you draw using Hess law an energy cycle diagram? Uh, there is one word which I wanted to add here. Actually, the correct word should be, because I want to teach you two different terms here. Draw enthalpy. This is the enthalpy cycle. The Hess law basically is to be called as the enthalpy cycle. Okay, so I'm asking you to first of all draw enthalpy cycle. So the moment I do that means I want you to use a Hess law diagram. First you draw an enthalpy cycle diagram. This is exactly going to be like this. There is no change. Arrows will always go this way. So you have to draw in your diagram, which must connect the lattice, the hydration, and the solution. So the first thing what you will do, as you did here, you will write the solution equation for the compound. So the question is of barium hydroxide, so write down the solution equation for it. So let me know if you are ready with it. So you write down the delta H dot solution equation for barium hydroxide. So barium hydroxide is here, solid, and you will put this in water. So complete the equation. Tell me when you're done. So when you dissolve this in water, you will get barium ions in aqueous, plus you will get two OH ions in aqueous, correct? Now what we are doing is we are using Hess law to complete the diagram, which is going to look like this. So I hope by now you understand what should come inside the box. Can you just quickly mention what do you think should be inside the box? You can look at the previous question. Guys, I need the chat to be little active, otherwise I will not know whether you are with me or what's happening. You guys can hear my voice? You can? Okay. All right. So what should be present here? Remember, I have to, when I use this diagram, I have to show lattice energy, I have to show hydration energies, and I have to show solution energies. So solution is already done. Now these two are left. So how do I show lattice energy? I have ionic compound solid here. So what do I need in the box to make the ionic compound? I need ions in gas, correct? So I need this ion and I need the two hydroxide ion. So if I have ions in gas, I can go here. That's my lattice. So this is my delta H dot lattice energy, which is already given as minus 2235. Are you okay so far? It's always going to be like this. Please let me know, are you comfortable? Yes or no? Y for yes, N for no. If everyone can answer, that will be very helpful for me. Just want to be sure that you're okay. Okay, and then I need gas. I need the gas changing into aqueous. What is this called? Gas changing into aqueous. Sorry, gas changing into aqueous means this is hydration. So that means arrow has to go this way. Okay, so barium is how much? Minus 1360. Hydroxide is minus 460, but this is times 2 because there are 2 moles here, don't forget. Now can you calculate this value? See how much you get. Write the answer if you get. Write the final answer. I'm waiting, guys. I'm not going to solve this. I'm waiting for you. Final answer of this. Okay, so you got a minus 45. Absolutely correct. Well done. Okay, now you got a minus 45. Okay. So your delta H dot solution was equal to, that will be 2235. It will become positive plus minus 1360 plus minus 460 times 2 is equal to, you guys said it's minus 45. Okay, now this is what is called as the enthalpy cycle diagram. But sometimes you may have to use what is called as the energy profile diagram. So let's have a look. How do we draw an energy level or energy change diagram or energy level diagram for the same question? So when it comes to energy level diagram, so you have to draw in the diagram once again the lattice energy, the hydration, and the solution. These three has to be in the diagram. So how do we draw it? So for this particular question, so this is the energy increasing. So always remember there are going to be three lines. So now you have to decide logically, does that make sense to you that the gas ions always will have the highest energy? Is that agreed by everyone? I'm just trying to save some time for you. So the gas ions always will have the highest energy. So you will put barium 2 plus gas ion and the 2OH minus gas ion at the highest energy level. Okay. Now, your lattice, your solution is also given and hydration is also given. Now look at your solution. Your solution is minus 45. If your solution is minus 45, remember if it is minus, arrow goes down. If it is plus, arrow goes up. Correct? You remember this? Everyone remembers this? Okay. Now guess what should I put in the middle line here? Should I put barium hydroxide solid or should I put ions in aqueous? The solution is minus 45. Solution is minus 45. Which means, do you understand that the barium hydroxide solid has to be here? And when you come here, this is the barium ion aqueous and the hydroxide ion aqueous, and that this is the delta H dot solution. Do you understand why is it going down this way? Because it is negative, correct? It's negative 45, yes or no? That means it has to come down. Yes, makes sense? Give me yes or no. Okay, now what about this one? Where is the lattice enthalpy then? From where to where? How do I show my lattice enthalpy? Lattice enthalpy should be from ion in gas to ionic compound in solid. Lattice enthalpy energy is always exothermic. So ions in gas to ionic in solid. So which means arrow has to come down here. So this is delta H dot lattice energy of barium hydroxide. Okay, now where is the hydration energy? Where to where? How do I show my hydration energy? Anyone has any idea? Guys, you need to open the mic and speak. If you're very quiet, then the class is going to go very dull. Either talk in the chat or use the mic. It's a small class. Don't make it very quiet. How do I get the hydration? Who changes to who? Go back on your notes and check last class.
So from gas to aqueous.
Okay, good. So that's the gas there, right? So which means
Yes.
from here to here is the hydration. Do you understand? Give me yes or no. Hydration is from gas. It is from gas to aqueous. Okay, so let me make a note here and tell me. Hopefully this will make you more comfortable. Okay, so note says whenever you make this kind of energy diagrams, what you have to remember is until you don't remember this very important concept. So when it comes to lattice energy, you must remember gas changes to solid. When you talk about the hydration, you must remember gas changes to aqueous. When you talk about the solution, you must understand the solid changes to aqueous. Please don't forget this. Until you don't remember this, it's very difficult for you to draw the diagrams. And you will end up, unfortunately, making a mistake. Okay, so now you know how to draw enthalpy cycle and how to draw energy level diagram. Okay, energy level diagram. So I'm going to give you another question where you will do the enthalpy diagram, you will do the energy diagram, and you will calculate the whatever value they want. Is that okay? Let me know if I can go to my next page. The good news is the enthalpy cycle diagram will never change. It will always remain like this. Arrows are always going to be pointing on top. Solution always will be on top. There won't be any change. Let me know if you're ready for the next question. Ready? A level, I told you, physical chemistry needs a lot of practice. Just learning the notes is useless, okay? So we have to spend time in the calculations till you are not perfect. Otherwise, the whole time will be wasted. Okay, let's have a look at this one. I am giving you delta H dot lattice energy for magnesium hydroxide solid equals to negative 2995 kilojoules per mole. Okay. Delta H dot hydration of the magnesium ion in gas equals to negative 1920. Delta H dot hydration for OH minus gas equals to minus 460. Question says A. Draw enthalpy change diagram. B. Calculate delta H dot solution. C. Draw energy level diagram. Okay, come on. Do the whole thing by yourself and type when you're done. Three things I want you to do. I hope you have some rough sheets and papers with you. These are some old past paper questions. You have to start drawing the enthalpy change diagram first by writing an equation to show the solution enthalpy of magnesium hydroxide. So you have to write delta H dot solution of magnesium hydroxide, that is the start. So you are going to take magnesium hydroxide solid and put in very large amount of water. Just trying to speed you up. Now complete the diagram. Let me know when you're ready. So this arrow will go up, this will go up, this will go up. Mg2 plus gas will come. 2OH minus gas will come. So this will be minus 2995. Hydration for magnesium is minus 1920. For OH minus it is minus 460, but times 2 because there are two of them. Okay, I have some answer coming up. Okay, Sonia. Very good. Very good. Haneen, Siddharth, correct. Talal, correct. Well done. So that's 2995. Signs will change. Hydration, magnesium is minus 1920 plus negative 460 times 2. This whole thing should come plus 155 kilojoules per mole. Sonia, is that correct? Anybody needs help? Okay, could you start working on your energy level diagram? Okay. How will you make energy level diagram? Now be careful. So when you make the energy level diagram, don't forget who has the highest energy all the time. All the time, the highest energy always will be with the gas ions. They will always have the highest energy. Now look at the value of this one. First of all, looking at the value of this, do you think magnesium hydroxide is highly soluble or less soluble in water? I wrote a comment earlier. Do you think it's highly soluble or less
Sir,
soluble?
it's insoluble,
Yeah, not insoluble, like it is soluble to some extent. So it's partially soluble.
partially
So
soluble.
yeah, so magnesium hydroxide, because it is quite positive. So magnesium hydroxide is less soluble in water. It is something called as partially soluble. Okay. So we understand that. Okay, good. Now gas ion has the highest energy. So now the question is, this is plus 155. So who should be in the middle line? Now you decide and you tell me.
Sir, would it be the aqueous ions?
Because the solution has to be positive, right?
Yes,
Positive arrow goes up.
yes.
So I hope everyone understood the logic. So if I keep magnesium hydroxide solid here, so from here to here, I can get Mg2 plus aqueous and the 2OH minus aqueous, and this is going to be called as my delta H dot solution, which is plus 155 kilojoules per mole. Because it is positive, we are going up. Does that make sense to everyone? Please confirm.
Yes, sir.
Yeah, everyone is okay. So because it is positive, that means the aqueous ion will have higher energy than the solid. But then where is the hydration then? Where's the arrow for hydration? You must refer to this what I gave here. Hydration has to be gas to aqueous. So where should I make hydration? Remember, hydration is from gas to aqueous. Solution is from solid to aqueous. So gas to aqueous. So does that make sense to you that this is the delta H dot hydration? Does that make sense to you? Is everyone comfortable? Why did you put it second? Okay. So Talal, what are you talking of the aqueous in the second line? Talal, are you talking about aqueous in the second line? Okay. Okay. So why I'm saying is, look at the value of the solution. Isn't that plus? So that means solid to aqueous is plus 155. Correct. So plus 155 means arrow has to go up or down. The concept says if it is plus, arrow goes up. If it is minus, arrow goes down. Do you remember this? So because it is plus, my solid to aqueous arrow has to go on top. So that's why I have to keep solid here at the bottom. That's, and then aqueous in the middle, because from solid to aqueous is plus 155. We are going up. But gas to aqueous, we are going down. It's negative. Negative we go down, positive we go up. So hydration is always exo. Don't forget, hydration is always exo. And why is it always exo? Because there is a new bond which is made between the iron and the water, iron dipole force. So new bonds are being made between the ions and the water molecule. So that is why it's always exothermic, which means hydration arrow always will be going down. Does that make sense? It always will be from gas to aqueous. If you're ready, can we do one final question from my notes, and then we'll do some exam questions? See, we need everyone to be like perfect and do this very, very quickly. If you're ready, okay, can I go to my next page? My teaching component finish is now only up to you how quickly you get the practice done. And one of the reasons I don't like to give homework is because the follow-up becomes very difficult. So let's make sure that we are finishing these questions today. Okay, so I'm giving you delta H dot lattice energy of calcium hydroxide is negative 2650. I'm not giving the units, you already know what they are. Uh, for hydration of the OH minus gas, minus 460. Hydration for the Ca2 plus gas is negative 1650. Okay, the question is as usual, calculate the delta H dot solution. That's the number one question. You could draw the enthalpy and the energy level diagram. Energy level diagram. Okay, I'll wait for you till you finish. For those of you who need some extra help, could you just check if this can help you? Very quickly, guys, could you just give me a second? Can you just write this formula and see if it works? Delta H dot solution equals to delta H dot hydration minus delta H dot lattice energy. Could you just confirm if this calculation works and you still get the same answer? Hydration in this case is negative 1920 plus hydration was negative 460 times 2 minus the lattice energy, which is negative 2995. Could you just check, are we getting the same answer, yes or no, using this direct approach? Like this is for those guys who don't like Hausdorff diagram also. Someone please confirm. Are you still getting plus 155? I need someone to confirm, are you still getting plus 115? Okay. So if you don't want to draw the Hess law, if you're running out of time, you can directly use this formula here. So solution enthalpy equals to hydration minus lattice energy. Halas. You can just directly get the answer. Is that okay? Happy now? Okay, you're talking for question 3. Yes, you are absolutely correct. Well done. Okay, so if someone can get me the answer, you want to use that format which I just gave you? Because sometimes they'll ask you to draw. So if you want to just calculate the answer directly, so delta H dot solution equals to delta H dot hydration minus delta H dot lattice energy. So you can go directly also. So hydration is given minus 1650 plus minus 460 times 2. Is that okay? Do you understand why is it times 2? Because it's 2 OH minus ions. This is hydration minus lattice is given to you minus 2650. Could you confirm what's the final answer? Are we getting a plus 80? Is that correct? Is there anyone else who got the same answer using this? Okay, so this is all done. So have you drawn your energy and enthalpy diagrams, please? Draw and tell me when you're done. Because drawing skill, you have to be good in this. Enthalpy change diagram. Remember, whenever you draw enthalpy change diagram, so you're going to write the delta H dot solution equation. This is for calcium hydroxide dissolving in very large amount of water to form calcium ions aqueous plus 2 OH minus aqueous. And then I'll always have calcium ion in gas here. I will have the 2 OH minus in gas here. Arrow will go up. The diagram never changes. That's the enthalpy change diagram. Is there anyone who needs any help? Okay, what about the energy change diagram? Energy level diagram? Tell me when you finished. Please type DN for done if you finish. The delta H dot solution is positive 80. The gas ion is always written on the top. The question for you is, where should I write the aqueous ions and where should I write the solid? Your solution enthalpy is positive 80. So positive 80 means calcium hydroxide solid should be here and calcium aqueous ion should be here. Talal, are you okay on this one now? Because this has to be the delta H dot solution, which is a plus 80. Does that make sense? So if it is positive, you will keep aqueous in the middle. If it is negative, you will keep aqueous at the bottom. Have you understood? Simple it is. And then hydration is always from gas to aqueous. So this is your delta H dot hydration. And your lattice is always from gas ions to solid. So gas ions to solid. This is delta H lattice. Now tell me if anyone has a problem in labeling. Lattice was given minus 2650. Solution you calculated. Hydration for calcium was given minus 1650 and hydration for OH was given minus 460 times 2. Is everyone comfortable now? You think you're ready to do exam questions? Yes, no? Would you like to have a small little break before we start the exam questions? Yes, that was a big yes. Immediately I got the response. Okay, okay, fine. Take a short break. So we're going to do break till so don't log out. We'll just finish this. Hi Jude. It's okay, don't worry. Once the class gets over, I'll send you the recording in the notes, okay? I'm exercising. guys, let me know if you're back. I'm going to share a file with you right now. For those of you who would like to have a clean copy of the file, so I'm sending one. We'll quickly solve this sheet. Then we have another sheet. This is all exam questions. So just make sure that you have received the file. Okay, everyone has received the file. Let me know. So we'll just quickly write down the answers as you're solving. First of all, check, have you received this file? Okay. All right. Off you go. Start solving as fast as you can. Anyone who cannot get the answer, then I will solve the question for you. The question did not tell you to draw the diagrams. If you feel drawing diagram is easy for you, then do it. Or you can do it without the diagram. I gave you a shortcut directly also. Delta H dot solution equals to delta H dot hydration minus delta H dot lattice. So directly put everything. Give me the final answer, please. So you must know this is sodium fluoride solid. In case you want to check the mole ratio, so it is all 1:1. Okay, so I already have an answer as -10. Haneen and Sonia confirmed. -10 looks to be the correct answer here. You can go on to the next question then. Hydration is -406 plus -506 minus lattice is -902 equals to -10 kilojoule per mole is the answer. Okay. Next question. So is -10 confirm the answer? Like only two people got it? Can anybody else also confirm? Okay, so the second question, if you have the answer. But this time question says find the enthalpy change of hydration of chloride ion. So according to the formula that we know, that delta H dot solution equals to delta H dot hydration, correct? We know the formula. So we can directly put that in the formula and check. Solution is given to you as -37 equals to hydration of lithium is -519 plus X minus lattice is given -846. So in this you have to solve for the value of X. So just check what is the value coming. So do we have a +290? We have only, okay. So we agree answer is +290 kilojoules per mole is the answer of the second question. Because this was for lithium and this is for chloride. Okay, is everyone okay? Can we go to our next question? Talal also confirmed. Okay. This one. In this question, the question says draw energy cycle to calculate enthalpy of hydration. See, the thing about the correct word is enthalpy and energy, but the way Cambridge will use in textbooks they will use the same thing for everything, which is very unfair. But draw energy cycle to calculate the enthalpy of hydration of magnesium ion. So you know how to do energy cycle? The solution, the solution is negative. So which means what I taught you just now, the gas ions has to be the highest. And this is the chloride ion. They have to be the highest. But the solution is negative. If the solution is negative, that means MgCl2 solid must be here, and when it dissolves in water, it is going to form Mg2 plus aqueous and 2Cl minus aqueous. And this is negative 55.
Sir,
And
but they said through an energy cycle, not energy level diagram.
second,
Sorry, sir. They asked us to draw an energy cycle, not an energy level diagram. The
oh,
question.
they use the word cycle. Oh, okay, you're right. But actually, I can get it from here as well because that is going to be X. But I think, yeah, the key word is the cycle, I guess. So that kind of makes it easy for you. Just draw the Hess cycle and finish it. Energy cycle. Okay, so you know what to do. Let me know if you have the answers. Please type in if you have the answers. Okay, someone already typed answer. Okay, so Haneen, which one are you talking about? Which question two? You could use the mic and speak. Are you talking the earlier question? Okay, guys, can we just check the previous question? There's a difference. Are you talking of this question? Is it not plus 290? Okay, so can we just cross-check this calculation?
Sir, I got the same for Haneen as well in the previous question.
Okay, what answer you got?
300 minus negative 364.
Negative 364. Is that correct, Haneen? Yeah, okay. Yeah, it should be negative, obviously, because it is exothermic. Guys, rest of you, could you just confirm? So negative 519 plus x plus 846 equals to negative 37. So x equals to negative 37 plus 519 minus 846. Is that correct? Just check. Someone just confirm. Is this correct what I wrote? Okay. So minus 364. I think that's okay then. Thank you. Okay, let's keep moving. And what about this one? So I have here Mg2 plus gas, and I'm going to have 2Cl minus gas. So this arrow will go this way. This will always go this way and this way. That's the Hess load. Okay, just put in all the numbers. So lattice is given as minus 2592. Magnesium is what you have to find. So that is the X. Chloride is given minus 364 times 2. Okay, and the solution is already given as minus 55. So minus 55 equals to 2592. So that's x plus negative 364 times 2. Anyone has the final answer here? What is x equals to? Find the value of x, please. Okay, do we have confirmation for minus 1919? Okay, we have confirmation. Okay, good. Let's keep moving. Is that okay? Let's keep moving. Okay, have a look at this past paper question. Very, very quickly. Past paper question. Come on. Use the above data to calculate delta H solution for magnesium hydroxide and strontium hydroxide. So first of all, let's find out for magnesium hydroxide. So hydration is minus 1890 plus minus 550 times 2. Everyone is okay? Like, why did I multiply this by times 2? Everyone is okay, right? Hydration minus the lattice is minus 2993. Can you confirm what's the answer here? Because it's 2 moles of OH minus, okay? Are you getting plus 3? Guys, are we getting plus 3? Like, I need at least 2 kids to confirm. Okay, so 2 people are confirming. So that's a plus 3 kilojoules per mole. Confirmed. Okay. And the other one, how do you find for strontium hydroxide? Same way. Find for strontium hydroxide. So hydration is given as now you have to use the strontium value minus 1414 plus minus 550 times 2, and the lattice is negative 2467. Anyone confirming how much is this? Are we getting minus 47? Very good. Okay, correct. Okay, so everyone is comfortable. No one has any problem about the calculation. Oh, well done. Okay, that's the end of it. So let me save this and I will send this to you right now. So this is also done. I'm now going to start entropy. Okay, just give me a second. There is one more worksheet given. So do I send it to you? Like, if I send it to you, the problem will be the same. I don't know, you will do it or not. And how do we check? Or do you want this to finish here only? Or should I make you do it when I see you in the face-to-face class next week? I can send the worksheet for you. You can start working on it, bring it to your next class. You want that to happen? Everyone, give me yes or no. Okay, so this is the worksheet. It has a few more questions. So what I'll do is I'll send this to you as well. So please bring it in your next class. So I will not start the next topic till this is not, all the answers are not checked and confirmed. Okay, so I'm sending this to you. So this is mandatory homework that you have to bring along with the Born-Haber sheet which is given to you. We will first check all the answers, match the answers. Anyone has a problem, solve the question there. Then we'll move on to our next teaching. So this is, please make a note. This is mandatory. Okay. So let me also make a note here. Sheet for solution and the hydration plus the Haber. Okay. So this will be to be checked in the next class. So this work must be completed in broad. Everyone agreed? Yes? Okay. I did not get the yes from you. Okay. Um, yes, only Sonia says yes. Good. So we are now starting our, there's a small discussion which is very parallel to the first thing that we did in terms of lattice energy. I'll just quickly finish this. Factors affecting the delta H dot hydration. So remember hydration, which is always exo, correct? First of all, do we know why is it always exo? Because since new bonds are formed between the ion and water. So the hydration enthalpy is always exo. So what are the factors which can affect the value of hydration enthalpy? That is what we are trying to understand. I'm sure you remember this particular point. Size of ion and charge. So it's exactly the same what we spoke in terms of lattice energy when we were talking. So the size of the ion must be small and the charge of the ion should be high. So what happens when ion is small and the charge is high? There's another set of words which I asked you to learn. Do you remember what they are? When the size of the ion is small and the charge of the ion is big, what does this amounts to? So this amounts to high charge density. Do you remember? High charge
Yes.
density, correct? So high charge density means, so we'll have high hydration enthalpy. Okay, so this is the story. So high hydration enthalpy, which means it's going to be more exo, which means it's going to be more negative. So this is the important point here. And very simple direct questions you will get. For example, if I give you fluoride ion versus chloride ion, which one do you think will have higher, more negative hydration enthalpy? Fluoride ion or chloride ion? What do you think? Similarly, I can give you, all these are past paper question. Magnesium ion and calcium ion. Which one do you think will have higher hydration enthalpy? Your guesses, please. Fluoride versus calcium chloride ion, magnesium versus calcium ion. So out of fluoride and chloride, you understand these ions are smaller ions. Because they are smaller ions, so they have high charge density. And because they have high charge density, therefore fluoride ion will have more hydration enthalpy than chloride, and magnesium ion will have more hydration enthalpy than calcium ion. Does this make sense to you? Give me yes or no. Everyone is clear? Okay. So that was a small thing which is left. So if you're ready, we are starting now 23.3 entropy. Let me know if I can go to my next page. Fluoride. No, Baba, size of fluoride, it has only two shells, no? Chloride has three shells. You might be remembering electron affinity. Fluoride has got only two shells, Baba. 2, comma 8. Chloride shell has got 2, 8, 8. Okay, so that's the reason why chloride has bigger in size. Okay, so now let's write down topic 23.3, which is entropy. This is a small topic. It will quickly finish. Entropy. Now, naturally, do you like to be in a state of order or disorder? What do you think? And be honest with me. Would you like to remain in a state of order or disorder? Do you keep your room very tidy and clean all the time? Or do you randomly throw things in your room? Guys, be honest with me. What do you think? Or do you want me to ask your parents? They will give me a more clear picture. Order, it's quite less. Both. Now you're being diplomatic. Normally teenagers will be in a state of disorder. I mean, come on, they're not going to keep the room very tidy and neat all the time. But most kids don't. But maybe as you're growing into senior kids, you do. That's well done if you do that. Really, it's good. Good on you. So entropy it's a measure of disorder in a system. Like how much is things scattered about? Okay, that it gives an idea how disordered something is. Okay, so by definition, it's the number of possible arrangement of particles and their energies. So the number of possible arrangement of particles and their energy. So that's in a given system. In a given system. So when we say entropy, it's like, just imagine a class in which everyone is roaming around here and there. That's a very disordered class. So we say entropy is high, where there's more movement, more randomness, more disorder. So just to make sure that you understand things, I'm going to give you some examples and you will tell me, do you think entropy is increasing or decreasing? Okay, one more point before we start. The entropy change, this is called entropy change. The unit is always joules per Kelvin per mole. That's the unit for entropy change. And so the point that I want you to keep in mind is that if the entropy change is increasing, so we say it's positive. If the entropy change is decreasing, we say it's negative. Okay, so what I'm going to do is I'm going to ask you some questions and you will think and tell me, do you think entropy is increasing? If you say increasing, you can just say plus. Or do you think entropy is going down? It's becoming. So remember, when there is more disorder, that's natural tendency of, that's what the Big Bang theory is based on. Universe is expanding because there's a natural tendency to expand, a natural tendency to be in a more greater sense of disorder state. So particles are
Sir, I was
moving.
just going to ask, isn't this related to physics?
Yeah. I'm talking of thermodynamics right now, cross curriculum stuff. Okay, so yes, you will study this when you study your laws of thermodynamics. Okay, so let's no thank you, one subject is enough for me. Okay, but in physics, when you study about universe, Big Bang theory, about the laws of thermodynamics, you'll understand that's a natural. I mean, I'll give you a very simple example. Morning in the assembly, you are forced to stand in lines, but you don't like it, but you've been forced to do it. But in a break time or in your free periods, when you go out to play, do you go in an ordered way? Or normally in the field, you are all scattered because that's a natural tendency to do, to be in a state of scatter, to be in a state of disorder. Okay, so that's being normal. So Having more disorder is normal. So next time you untidy your room, your parents go ballistic on you, you can say, oh, it's because of entropy, but don't take my name though. Okay, here's an examples for you. Okay, so I want you to tell me, according to your opinion, do you think entropy change is being positive or negative? So when you say entropy positive, it means you are saying it's going to be more disordered. Okay, so entropy positive means more disorder and less disorder. Everything in terms of less disorder. Of course, you can say less disorder means more ordered. Yeah, you can say that. More disorder means less order. I mean, but then try to just stick to one word. Example number one, boiling an egg. Please ignore the outer shell of the egg. You tell me, according to your logic, do you think entropy is going to be positive or negative when you boil an egg? Just to get your
Positive.
attention, this is almost an 8-mark question in the exams in paper 4. I'm not joking, 8 marks, okay? And try to use your Zoom chat as much as possible, okay? Let's keep the mic for emergencies, yeah? Just put plus or minus in the Zoom chat, everyone, please. So when you boil an egg, you must understand initially it's liquid inside, it's now changing to solid. So everyone agrees that so entropy change is negative. Everyone agrees to it because it was liquid before and now it's turning into solid, correct? Okay. Here's the second example. What if I give you this situation? Melting of ice. Melting of ice. Now think, is it going to be plus or is it going to be minus? Just write plus or minus. Melting of ice. So H2O solid, when it changes to H2O liquid, do you think entropy is becoming more or entropy is becoming less? So entropy change in this case is becoming positive. And why is that? Because solid particles are changing to liquid, so there is going to be more movement. There is more movement in liquid state, which means particles can arrange themselves more. There are more different possible arrangements, right? So that's why entropy is increasing. Okay, I need to go to my next page. So you need to tell me if you have copied everything from here. Can I go to my next page? My third example is, let's say I want condensation. Let's talk of H2O again. H2O gas changing into H2O liquid. What do you think now? Condensation. Gas changing into liquid. So you are saying that the entropy change is becoming negative. It decreases. And why? Because the particles are coming closer. So what happens when particles come closer? So stronger attractive forces present. So because there are stronger attractive forces present, therefore less movement. Okay, is everyone clear on what I'm writing? Less movement. Okay. Now, for example, reaction number 4, this also was one of the recent past paper I saw. Calcium carbonate to form calcium oxide plus CO2 gas. What do you think of this? Is entropy increasing or decreasing at this stage? Very good. Now what you see here, this is gas. So your entropy change is positive, increases, more disorder. And the reason why there is more disorder, since there is more gas moles on right hand side. Is this clear with everyone? Okay. Now what happens if temperature is increased? What happens to entropy change now? If temperature increases, entropy change also becomes positive. Why? Since why does it become positive? Because as you increase temperature, as temperature increases, the average kinetic energies increase. Correct? So that means there is, now don't talk of number of collision. I'm not talking of rate of reaction here. So if there is a average, they will have more kinetic energy. Correct? So that means there will be more movement. They will move more. We are only talking of different movements. More the possible movements, more the different arrangements possible. So it is happening. Okay, reaction number 6. Question number 6. N2 gas plus 3H2 gas. Now, what do you think is happening in this reaction? This is the famous Haber process equation. Do you think entropy is increasing or decreasing? Sorry, it's not aqueous. Sorry. It's gas. Okay. Now everyone is gas. How to solve this question now? You will count the total number of gas moles. You notice there are 4 gas moles here. But notice here there are 2 gas moles. Now you already know one gas mole has 6.02 into 10 raised by 23. When there is less gas moles, there will be less gas molecules. And if there is less molecules, your entropy will be less. Very correct. So here you will say entropy is negative. It is decreasing since there is less gas moles on right hand side. Okay. Anyone has any question? I need to go to my next page. So we are done now. I'm going to now show you some calculation question which comes on entropy. And once we finish that with whatever sheets, and that's it. We are done with this topic also. Then we have to discuss the last one, which is 23.4 Gibbs. So which I'm hoping that by next class we will finish everything this lesson. Let me know if I can go to my next page. If anyone has any question, any doubts till now. Everyone is okay? Okay. Right. So next heading is calculations, entropy change calculation. Now, before I start the calculation, there is something very important that you should know. Just so that you don't get confused, if you look at the textbook, you might find this formula. Entropy change total equals to entropy of the system plus entropy of the surrounding. You may find this beautiful formula somewhere, but this formula is not in Cambridge for you. Okay, then another formula you will find that the entropy change of surrounding is equal to negative h by t. This formula also is not in your IG syllabus. Oh sorry, A level syllabus. So the only formula that you have to know is how to calculate the entropy change of the system. This is the only one in A level. Have you first of all understood? So when you look at all these beautiful formulas in any resources that you have, please understand for your A-level chemistry, what you need is only the, but I have written the other formulas which are good for your entrance examination. So S total, if you have to find system plus surrounding, this is the formula to find surrounding, minus H by T. In A-level Cambridge is only system. So entropy of a system equals to, this is called the sum of, this is the sum of entropy of the product minus sum of entropy of the reactant. This is product, this is reactants. That's it. Very simple formula. So this is the formula that you should know. Let me know if you're ready. We'll do some questions. If you're ready, we'll start. Okay. Now, don't forget a very important information. I said entropy change. The unit is always joules per Kelvin per mole. Okay, so don't forget that. Okay, so let's have a look at a simple question to begin with. I have given an equation: 2 magnesium solid plus O2 gas gives 2 MgO solid. The delta H for this reaction, oh no, not delta H, the entropy in terms of joules per Kelvin per mole for each of the species I am giving. Okay, this is for magnesium solid, for oxygen gas, and for MgO solid. So for magnesium solid, it is given as 32.6. For oxygen, it is 38.2. Oh, sorry, it's 205. And for MgO, it is 38.2. Any surprises as to why oxygen has very high entropy compared to others? Are you surprised why oxygen has high entropy compared to others? Or do you think this was expected? Oxygen is a gas. Yeah, so it's going to, yeah, it'll have very high entropy. Okay, I've given you the equation. Your job is to calculate entropy change of the, so when we say entropy of the system, when we say find entropy change, is only for system for you. So I've already given you the formula. So let me know when you have the answer. Product minus reactant. Product minus reactant. I have 2 MgO. So that is 2 times 38.2 minus the reactant. I have 2 magnesium. So that is 2 times 32.6. I have one oxygen also, which is 205. Please solve. Give me the final answer and tell me if it's plus or minus. Guys, final answer please. Is that a 216? Are you sure? You want to check that again? Minus 193 is the correct answer, but check the decimals. Are we getting a minus? Okay, are you telling me in kilojoules per mole or joules per mole? So are we getting a minus 193.8 joules per mole? Yeah, is that what you're getting? Can someone confirm? Minus 193.8, or you can say minus 194 joules per Kelvin per mole is also okay. Okay. So let's do a couple of more questions before we get to sheet. Can we do one more quickly? Okay. So let's have a look at another one. That's the N2 gas plus 3H2 gas gives 2 NH3 gas. The entropy values in terms of joules per Kelvin per mole for each of the species given is for nitrogen it's 192, for hydrogen it is 131, for ammonia it is 193. Okay, go ahead, get me the final answer. The question is find enthalpy change of the system. Like basically your syllabus just says find entropy change, but they don't use the concept of entropy total. So they will just say find entropy change. That's it. They won't specify this system. Okay, so this is how most of the time your past papers will show the question. Find entropy change. So, but you know that the entropy change equals to sum of entropy of product minus sum of entropy of reactant. Sum of means add up everything, total everything. Still waiting for the final answer. So for product, I have 2 ammonia, that is 2 times 193, minus reactants, I have N2, which is 192, plus I have 3 moles of hydrogen, that is 3 times 131. This should give me the final answer. Are we getting a minus? No, check again. Minus 668. Are you sure? Check again. Yes, we are getting a minus 199. Thank you. And don't forget that's joules per Kelvin per mole. Is this okay? Anyone has any questions? No? Okay. Okay. All right then. So let's have a look at some exercise. Just give me a second. Okay, I thought I had kept some copy. Just give me a second, guys. Just give me a few seconds. Okay, is the Word file opening which I just shared? Just check. Are you able to open it? Guys, I just sent a Word file. I just want to see if you are able to open it. Okay. All right. We're not going to do every question. Just a few. Just a few. We're not going to do every question. I have three here. We got some questions there. Can we just do for one of them for now? Can we do question A, please? Can we do this one? I'll just wait for you to solve this question and get me the final answer. Only for the first one, A part. You did this in school? Okay. Yeah, it's from the textbook. So see if you can get the final answer now. Product, I have 2 times H2O. How much is H2O? That's a 69.90 plus oxygen gas 205 minus the reactant, that's 2 times hydrogen peroxide liquid, that's 109.6. Interestingly, in paper 4, this is a very popular question. It's good 2 marks for you. Okay, Hanin says it looks to be a plus 125.6. And don't forget the unit, joules per Kelvin per mole. Can I get one more person to confirm, please? So, can I assume that everyone is quite comfortable how to find entropy calculations, right? Okay. So the next question on this one is, I think it's the same idea. Okay, it's the same thing. So maybe at home you can have a go at it. Is that okay? Or do you want to try one more? Or you think it's okay? You got the idea, right? How to do this? Okay. So I've already sent you this file. So have a go at it. Try to complete all the questions. And then what we can do now is I'll just write down the next heading, what I'll take when I see you again. That's the last part of the lesson, which is 24.4. I finished 23.43. So the next thing what we are going to do is topic 23.4. This is the last one, and that is the Gibbs free energy calculations. Okay, so we'll talk about Gibbs free energy change. what is the significance, and what do we do with it, how do we calculate it. So delta G dot. Okay, so that's what we'll be discussing to finish off the lesson. So that's going to happen. Once again, don't forget the new lesson after that is going to be topic 25, equilibrium, not topic 24. Okay, so we'll do topic 25, finish that because these are all calculations, and then we'll come back to electrochemistry. So that's the sequence. Okay, you have any questions for me regarding today's session? Okay, Talal, is there any way we can come to know what's happening with Hisham? I think he's missed today's class as well. So I don't know if he's still in the group or no. I'll send him a message though. Um, anyone has any questions for me? Okay, yeah. All right, I'll just send him a message. Yeah, that's fine, no problem. Okay. All right then. Everyone got all the copy of the notes what they wanted?